Now let's look at solving quadratic inequalities by looking at a couple of trick problems, or so-called trick problems. So if you think about quadratic inequalities, you basically have some type of inequality that looks like this, greater than or less than, where this right here, this could either be less than or equal to, less than, greater than, equal to, or greater than. And if you think of that, what you're really doing is you have an xy graph and you have a parabola. So one thing that makes this pretty easy is that the only place that a polynomial, or in this case a quadratic, can change signs is when it crosses the x-axis. So what you do is you find, the basic strategy is you find the x-intercepts, and that tells you where the signs change. So that divides x into regions, and then you can tell if each region is either positive or negative. The trick comes about, or a trick problem comes about in two cases. One is when you have a tangent. So for example, you have some type of parabola maybe that looks like this. Or another case is when there's no x-intercept at all, when it might look something like this. They could also, just as easily, it could be tangent down, or there could be no solution down, right? Either one of those are possible. But in that case, if you notice in this case, you're only going to have one region. You're only going to have one x-intercept, so you're going to have two regions. It gets a little tricky when you talk about this x-intercept here. Here, actually, you only have one region, so that it's always either going to always be positive or always be negative. So let's look at some examples, and that's the easiest way to do it. So let's say we have x squared minus 6x plus 9 is less than or equal to 0. That's an example. And then the first thing you're going to do is you're going to solve for the critical value. And that's where the x-intercepts are. So in this case, I'm going to factor. You're always going to use factor or quadratic formula. This, I think, is going to be x minus 3, x minus 3. Let's see if that's right. Negative 3 times negative 3 is positive 9. Negative 3 plus negative 3 is negative 6. That's right. So the critical value is x, the solution, x minus 3 is equal to 0, or x equals 3. So you have a number line here, and the critical value is x equals 3. Now, you have to think about whether or not 3 itself is a solution or not. Well, if it's less than or equal to, see if you have the equal part, then that means 3 is going to be a solution. And then what you have to do is you're going to divide this into two regions, and you're either going to see if this side is positive or negative, and then see if this side is either positive or negative. And the difference when there's only one x-intercept is that they could both be positive or they could both be negative. So what you do is you're just going to plug a value in. This is x equals 3. I'm going to plug in here x equals 0. So I have 0 squared minus 6 times 0 plus 9. 0 minus 0 plus 9 is 9. That's a positive number, so in this region the polynomial will be positive. Then you look at this region. Let's choose x is equal to 5, say. So then you have 5 squared minus 6 times 5 plus 9. That's going to be 25 minus 30 plus 9. 25 minus 30 is minus 5 plus 9 is going to be 4, so that's going to be positive. Well, so both of these are positive. So this is positive and this is positive. At this particular point, it's equal to 0. What you're going to see here then is you want all positive values. You want all negative values, or 0 values. This is not negative, that's not negative. That right there is the only place where the solution is. So the solution set here is going to be x is equal to 3. And that's the only place that this statement is true. The trick comes in is let's do exactly the same problem, but let's have x squared minus 6x plus 9 is less than 0. Right? So the only thing we're changing is this less than or equal to the less than. In that case, we'll have exactly the same drawing, right? Exactly, because we're doing the same problem. 3 is the critical value, but in this case, 3 is not a solution because it's strictly less than 0. At the critical value, x is equal to 0. I'm sorry, y is, the critical value, y is equal to 0. So here what you're going to have is this is not a solution, this is positive, and this is positive. So here, what's your answer? Well, this is not an answer, and this is not an answer, this is an answer, so here there's no real solution. Sometimes that's called the empty set, and it has a symbol that looks like that. If you had exactly the same problem, except for it was x squared plus 6x plus 9 was greater than or equal to 0, we'd have the same drawing. We'd solve for the critical value, which was 3. At 3, y is equal to 0, so that is going to be a solution. It was positive here and positive here. We do that. Remember how we did that? We simply took a value in this region and plugged it in. We found out that the two regions were positive. In that case, you have a positive, and a 0. We want where it's greater than or equal to 0. So there the answer. All values of x, or all real numbers, however you'd like to say that. So that's one example of a trig problem. And that's the case of a tangent. Graphically, it'll look something like this. You have an x and y. You have an x-axis and a y-axis. The curve is tangent to the x-axis at the point. The other possibility is that there's no x-intercept at all. Let's do an example of that. Let's do x squared plus 2x plus 10 less than or equal to 0. In that case, we're going to solve for this. I'm going to try to factor this. It turns out that I can't factor this, so I'm going to use quadratic formula. So I'll go x is equal to minus b plus or minus b squared minus 4ac over 2a. In this case, a is 1, and b is 2, and c is 10. So I'm going to just plug some numbers in. So that's minus 2 plus or minus b squared is 2 squared minus 4 times 1 times 10 over 2 times 1. I do what's in the square root first. I get minus 2 plus or minus, then that's 4. 4 times 1, 440. Then 4 minus 40 over 2. That's minus 2 plus or minus square root of minus 36 over 2. At this point, since you have a negative under the square root, then that means there's no x-intercept. There's no real solution, and x-intercepts are simply real solutions. So what you have here is you have no x-intercept, which means you just have one region. Graphically, that's going to look like a number line. Plug in any value you want to, it doesn't matter. I'm going to plug in x equals 1, and I get 1 squared plus 2 times 1 plus 2, 10. And I'm going to see if that in fact is less than or equal to 0. Let's see, that's 1 plus 2 plus 10 less than or equal to 0. That's 13 is less than or equal to 0. Is in fact 13 less than or equal to 0? It's not. So there's no solution here at all. So your answer is no real solution. So if you want to think about it, anytime you use the quadratic formula and you have no real solution or no x-intercept, you can think of it in a sense as a trig problem, because what you have is you have not critical values in regions, but you simply have one region. And your answer will, in that case, will always be either all real numbers or no real numbers. And that's how you do quadratic inequalities.